All right, so let's put some information from that video to use and get some practice in. So we're going to apply our algebraic thinking to write some equations and solve them using the radical symbol or the root symbol. Same thing, right? So we're thinking of some number, some base number has been squared and it equals 36. And remember, what this means is we have a perfect square. I'm not going to be able to draw this, I'll try. We have a perfect square and there are 36 units in it. So right now you're thinking, what number multiplied by itself gives us 36? And we know that that's 6. But we're going to show this, we're going to solve this like we are later in when we do some of our algebraic equations, some more complex ones, that is. So remember that this symbol meant the square root. And if we want to find any other root, like if this exponent's a 3 or a 4, then we just indicate that number here. But when we don't have a number here, it's automatically finding the square root. This number has been squared, so we're going to find the square root. And even though we already know the answer, we need to be able to show it using our radical symbol to show that we're doing the inverse operation to find the value of the unknown number. So this square root symbol and this 2 cancel out because we're undoing that. And this tells us to figure out what base number was multiplied by itself to get 36. And we know the answer is 6. And then we circle or box it in and we're done. So let's do another one. Let's do a fraction. Now this is going to work the same way, okay? You're just thinking what numerator was squared and what denominator was squared. So we're going to rewrite this using our radical symbol. And these cancel out. We're left with x equals some number multiplied by itself gave us 49. That's 7. Some number multiplied by itself gave us 25. That's 5. And there's our answer. Let's do another one. We're going to do x squared equals 9/4. So I want you to try this, pause the video and do this on your own, and then come back and see if you got it right. So you should have gotten 3 halves because 3 squared is 9 and 2 squared is 4. Okay, let's do another one. Some number squared gives us 1/4. So we rewrite it with our radical symbol. Those cancel. So what number squared gives us 1? Well, that must be 1. And then 2 squared gives us 4. So 1/2 squared gives us 1/4. And if you guys ever get stuck, try writing it out. Okay, if you're not sure, it takes a bit of practice to think backwards from our perfect square number to our base or root number. But if you're not sure, you can write it out. And what I mean is, like for the example over here, if I have 3 squared times, or 3 halves, excuse me, times 3 halves, so basically this is 3 halves squared, does that equal the number up here? 3 times 3 is 9, and 2 times 2 is 4. Now these numbers, obviously, they're pretty easy to work with, right? This is how we do our introductions to the new math, but they get more complicated. And so these strategies that you think about with easier numbers can be applied when you get into more difficult numbers. Also, guys, remember, put boxes around your examples. Whoa, that was a crazy box. Hopefully better than mine. And you should have your graph paper notebook so you can follow the lines in there. But this just really helps you stay nice and neat to know exactly what numbers are part of what problems. So it just really identifies the separate problems there.